Okay, so we're just going to do example 4. This is the last example of this lesson. Question asks, given the following logarithmic function, h of x equals to 2 log base 2 times negative 3x minus 6 plus 4, and I have to sketch the graph of h of x. So when I'm sketching this graph, I need to first of all factor out the negative 3 from there, so I have the k value as well as the d value specified. Along with that, I am going to draw myself table of values for my key points as well as for my transformed key points, and then look at my vertical asymptote and then graph right there. So let's go ahead and do those steps. The first thing is just going to go ahead and factor out the negative 3. So log 2 negative 3x plus 2 plus 4. Okay, so now I know the a value is 2, the k value is a negative 3, d value is a negative 2, and my c value is a positive 4. Okay, I'm going to make a table of values for my key points. That's x and y. So y here is going to be log base 2x, and my transformed key points, and as we know that the y values is affected by parameter of a as well as c, so it's going to be 2y plus 4, and the x values are affected by a parameter of k as well as d. So this is going to be x, so it's a negative x divided by 3, and then I have a minus 2. This basically essentially says that I have a reflection in the y-axis. There is going to be a horizontal compression by a factor of 3, and there's going to be a horizontal shift 2 units towards the left-hand side. Okay, and just carrying that on, I have a vertical stretch by a factor of 2, and as well as vertical shift 4 units upward. So my key points here, the values of y is always going to be 0 and 1, and I have to figure out what is the value for x. Converting any logarithmic to an exponential function, this is going to be 2 to the power of y equals 2x. So if the y value here is 0, so 2 to the power of 0 is equal to 1, and 2 to the power of 1 is going to be 2. Now I'm just going to transform them to get myself my new point, and I'm going to use my calculator here because I am going to be dividing by 3 and subtracting 2, so I need to have decimal values, especially when I am graphing. So bringing my calculator here, so 1 multiplied by negative, so it's going to be negative 1 divided by 3. Just going to turn this on, clear all that out. So it's going to be negative 1 divided by 3, and then I'm going to subtract 2 from there, so I have negative 2.33, so negative 2.33, and the y value here is just going to be 0 times 2 is 0 plus 4 is 4. And doing the exact same thing with the 0.2, so just going to clear that out here. So I have negative 2 divided by 3, so negative 2 divided by 3, and then minus 2 from there. That's a negative 2.67, and my y value is going to be 6. Okay, now I'm going to indicate what my vertical asymptote is. My vertical asymptote is essentially going to be my d value here. So it's x equals to d, so x is equal to negative 2. Okay, let's go ahead and sketch our graph now. When I'm sketching my graphs, I always like to look at what my x values encompasses and what is my y values encompass. So in this case, I have x values that are more towards the negative side, so I'm going to focus on the negative side of my x-axis. So negative 1, negative 2, negative 3, negative 4. That's my x-axis, that's my y-axis. And my y values go from 4 and 6, so I have 1, 2, 3, 4, 5, and 6. Just going to draw my key points. Start off by drawing my vertical asymptote, which is x equals to negative 2. X equals negative 2, and just plotting my key points now. So I have negative 2.33 and 4. So negative 2.33 is this right here is negative 2.5, so it's just going to be a little bit closer to negative 2. So it's negative 2.33 and 4, and you can approximate here. You don't have to be very precise, but do approximate your values. And the next one is negative 2.67, which is going to be towards the left-hand side of negative 2.5. So negative 2.67 and 6. Right there. And once you have the two key points, you can actually see how the graph is going to be looking like. So this is going to be approaching the negative 2 values, and that is going to be extended outwards. That's my function of h of x. I'm just going to go ahead and label it. So h of x equals to 2 log 2 negative 3x minus 6 plus 4. Great, so that's my function. And for part B, I'm just going to write down the domain and range for h of x. So for my domain, I'm going to span my x values here, and I notice the fact that my function approaches negative 2 but never touches it, and it's always going to be less than negative 2. So my domain, d equals x such that x is going to be less than negative 2, and x is an element of all real numbers. And my y values, I have all of my y values spanned here, so there's absolutely no restrictions. So my range is going to be y such that y is an element of all real numbers. Alright, great. And that concludes example 4, and I just want to let you guys know for some reminders as well as your homework. So homework fun, we're now going to change that to, instead of home fun, this is going to be school fun. So you guys are going to do your homework in school now. You are to look at these questions and try answering them. If you want to get a little head start right now, you may do so. But we will be working together in groups and doing a lot of those questions in class. Just a reminder, we need to watch video for lesson 4. That's going to be posted on Wednesday evening on Power Law of Logs. You need to take notes, copy examples, etc. and be ready to complete your homework for lesson 4 in class on Thursday. Perfect. Have a good day.